This new Spitzer image has unsheathed the sword of Orion and led astronomers to a treasure trove of baby stars within.
This is the hidden universe of the Spitzer Space Telescope, exploring the mysteries of infrared astronomy with your host, Dr. Robert Hurt.
Orion the Hunter is one of the best-known constellations in the sky. Hanging beneath its distinctive three belt stars is a glowing patch known as the Sword of Orion, or M42. At a distance of about 1,300 light-years, this nearby stellar nursery is easily visible to the naked eye. But for astronomers studying the Sword of Orion, visible light alone just doesn't cut it. We see only the small patches where young stars heat the surrounding gas and make it glow. The bulk of the Orion cloud complex is a mostly dark swath of dust and gas, containing the mass of about 100,000 suns and spanning 250 light-years. The infrared eye of the Spitzer Space Telescope can see this dust directly and identify the vast population of infant stars buried within. Spitzer can find young stars by detecting the infrared glow from their surrounding dusty disks. The very youngest stars are gobbling up material from their disks and growing larger. Later, the leftover disks around adolescent stars can provide the resources for building planets. Our tour of the Orion Nebula starts with the brilliant cluster of 1,000 stars residing in a bowl-shaped cavity in the larger cloud. 4 of these stars, known as the trapezium, are massive giants. Their dust-destroying ultraviolet light alone was enough to hollow out most of this cavity. The most prominent infrared feature here is the next generation of massive stars, which are completely hidden in visible light behind a fold of dust. Their expanding shock waves heat the gas around them, producing a brilliant green glow. Most of the stars in this ultraviolet-drenched region have dust disks, and astronomers are studying how this affects the potential for planet formation. Dr. Tom McGath, the lead investigator of this project, explains.
These environments, these hot environments around massive stars like there's in the Orion Nebula where there's a lot of UV radiation, may have a dramatic effect on the disks. It may actually sort of erode and basically evaporate the disks. While in contrast, the disks that are far away from it and more isolated in small groups or in isolated regions wouldn't have to deal with those kind of processes.
Looking to the north of the Orion Nebula, we find a colorful region laced with dark veins of dust. The stars here appear to be forming in an orderly progression, with older stars on the left and younger ones on the right. Many of the green blobs here literally point to nearby star formation. As infant stars feed on their surrounding disks, they eject fast-moving jets of material. When these jets slam through distant parts of the surrounding cloud, they produce shock waves that glow green in Spitzer's vision. Even to the south, where there are no massive stars lighting up the dust, modest-sized stars are clearly forming in abundance.
These are features that you can see throughout the region, and one thing that you can actually do with this data is trace back the jets to find where the stars are. And you can look at the morphology of the jets and their shapes, and you can try to figure out which star is generating which jet.
Dr. McGath and his team have used this data to make the most complete census to date of star formation in Orion. They have identified about 200 growing baby stars and over 2,000 young stars with planet-bearing disks. That's a lot more than we knew before, but the demographics of this census are even more important. If we think of the main Orion Nebula as a large metropolis of star formation, then about 60% of the stars were born in the big city, with 15% coming from smaller towns or clusters. This leaves a surprising 25% that grew up in isolation, far more than expected. Astronomers are working to understand more about the differences between these stellar city slickers and country bumpkins. This may someday help us figure out where and how our own solar system was born.
The Hidden Universe is produced by the Spitzer Science Center at the California Institute of Technology in Pasadena. The Spitzer Space Telescope mission is managed by NASA's Jet Propulsion Laboratory.